Hello, good day, everyone. I am here to present now uh, my research titled IoT-based detection, monitoring, and automatic cleaning system for soiling in PV solar panels. Together with me is my co-author, Professor Dr. YQ Nguyen. Okay, this is the flow of my presentation: problem and the settings, review of related literature, methodology, and results and discussion, and lastly the conclusion. Okay, we'll begin now with the background of the study. So, as you can see in the figure or in the picture, this is a solar PV panel affected by the dust accumulation. So these damages can done by the effects of the dust accumulation. So that will cause great loss of power. In order to avoid losses, so researchers study technologies to devise countermeasures of soiling phenomenon on PV modules. So this study implements easier and hassle-free detection and monitoring system for photovoltaic panels with the aid of IoT. The hardware design consists mainly of microcontroller that connects sensors and Wi-Fi module. Dust sensor for collecting the data gathered of dust density level and camera module for monitoring the physical parameters of the PV solar panel. So we have here a percentage contribution of different continents of the study of the dust accumulation. So particularly in Asia, we have also we have high dust accumulation, 55%, compared only to South America, 5%, because that is notably because in South America that is country there have cold country, whereas in Asia we have many tropical country, specifically in our country, Philippines. So soiling plays a great role in degrading of the performance of the funnel. So the dust accumulation lessens the efficiency and creates hotspots in the funnel. So here in objectives, we have number one is to develop so an IoT-based detection monitoring for the accumulation of the dust in the panel. And then we have to develop a automatic cleaning system, then deployment of the system in 3D verification, and then we have to visualize and analyze the data gathered. So let's go to the significance of the study. So what is a comparison with the existing system and the our system? So in the existing system, in order to clean the dust in the solar PV panel, there could be a existing manpower needed to clean the solar panel. So no data gathered also for the soiling phenomena in the panel. So in our system, we have maintain high performance of the PV solar panel, and also we have to listen the power loss for damages in the panel. And then also we have to listen the manpower needed. So this study uh, provides an automatic detection and monitoring system of the soiling phenomenon in the PV panel that would cause unwanted degradation of the panel's performance. So the system will benefit any company that is producing PV modules because the detection and monitoring of PV panels would be a great impact on assessing the efficiency of the PV solar panels. So in the scope and limitation, so this study focuses only on the detection, monitoring, and automatic cleaning of the soiling phenomenon in the PV solar panel. So the measures, this measure the dust density built up in the panel, in which would affect the efficiency of the power gathered by the panel, and send data through the Internet of Things. So this study would increase the efficiency of the funnel and decrease the manual labor, since it will have an automatic cleaning system capable of wiping dust out of the panel. So let's go now to literature review. So we have gathered here some existing literature that is commonly relates to this study. Also, we have some of the related studies. So we have here the authored by Manyufi Karim et al. Dust accumulation of the surface of photovoltaic panels, introducing the photovoltaic soiling index. So and also have a here authored by Herman et al. The soiling and self-cleaning of PV modules under the weather conditions of two locations in Arizona and Southeast India. So mainly this literature is only gathering characteristic surface texture coating of PV funnel. So meanwhile, in this literature also, entitled Quantitative Analysis of Dust and Soiling on Solar PV Panels in the Topics Utilizing Image Processing Methods. This is authored by Yap, Y. Ken et al. So this is utilized only on the image thermography of a solar panel without any wiping the dust accumulated in the solar PV panel. So in the mentioned literatures, we have in general, dust accumulation is a major concern for PV systems. So as it limits the sunlight transmitted to the surface, and thus the energy transferred from the modules is generated. So it means efficiency is affected. So let's go now to the methodology. So we have a system overview, and then we have system design, block diagram. So in the system overview of the study is illustrated in this figure. So wherein the sensors are installed in the PV solar panels in 3 different locations. So each detection and monitoring system is composed of 4 sensors, namely optical dust sensor. So that would detect the dust of the position of the panel. So MCP 3008, an analog sensor that would be responsible of showing us the voltage output of the solar panel, and temperature sensor that would detect the ambient temperature and humidity. So in the flow diagram, we have here some sensing unit. We have now the humidity and temperature sensor and the dust sensor. This is processed actually in a microcontroller, and then broadcast in the web server channel in the CPU, and this can be monitored in the visualization using smartphone or laptop. So in the schematic diagram, we have also here, and then the graphical user interface, we have used the Blink app. So you have set here the setted threshold before the wiping mechanism is to triggered in the prevention of the dust. So as you can see here, the dust display is we have accumulated, and we set the threshold level to 9,999 micrograms per cubic meter. So after that, if that set threshold is attained, so that's the time that the wiper will wipe the dust accumulation. Okay, so results and discussions. So we have characterization of dust monitoring. We have here setted the 4 key points: the dust accumulation, setting up threshold value and output voltage, and also the efficiency. So we have deployment of the system. So our prototype was deployed 3 different locations. So namely in Cebu City, Pasig Beach in Talisay City, and Argao, Cebu Province. So these are the 3 different locations that the system was deployed. So we have also data representation. So we have represented here based on the gathered data, the dust accumulation, the panel, output voltage, and also the temperature. So we have here the data of Cebu City, which is a dense area, particularly more on dust accumulation because this is situated in the city. Okay. So you can see there are offset of the set threshold level value. So that's why the output voltage is also affected. And then this is the deployment or the results of the gathered data in the beach resort in the Talisay City. And also in Argao, this is the results of the gathered data. Okay, we have here presented in the data chart, voltage output, dust accumulation, humidity, and temperature. So for conclusions and recommendations, we are concluded that the dust accumulation greatly affects the harnessing of energy. And also, it affects the efficiency of the harnessing of power of the solar PV. So, and also we have self-cleaning reduces the manual labor and increases the efficiency of the panel. So if the solar PV is regularly monitored of the dust or regularly clean on its dust accumulation, so it increases the efficiency of the panel. It harnesses more power. And then also, lastly, we could recommend the use of image processing and thermal imaging in analyzing the soiling in the solar panel. And that's all. Thank you for listening. Thank you very much and have a good day.